Hi guys, how are you? I hope you guys are doing well at home. I just wanted to start getting into this quadratic problems. We're going to be starting factoring, and we have some word problems we want to try. So we're going to go through those, try and take out your notes, copy them down, see if we can answer any questions. If you get stuck, you can always come into my office hours after school or on Wednesdays and make sure you ask me questions. Okay. So we're going to start with these, and we have this graph here. The graph at the right, it shows the path of a rocket that's launched into the air. It's launched from a hill above a lake, and the rocket's height above the surface of the lake is given by the following equation. So you could probably make some pretty good guesses or some pretty good guesses about what's going on, where t is going to be time. And h of t is going to be my height of the rocket. Okay. So in your notes, you should definitely write down the date. You should write down the title, and you should draw the picture with the labels of A, B, C, D, E, and F in your picture. Okay. Now, we've been working with all kinds of things this year with shifts of graphs and intercepts and increasing, decreasing, and we just want to keep on using all that information and connect it with everything you already know. So the first thing that I want to know is, can you rewrite this equation in standard form? So standard form is when you just start with whatever squared, like t squared, then t, then a number. It just goes in order. So if you were going to write out this equation here, you'd have to ask yourself, what would you do first? Well, would you multiply by negative 16 or would you square it? All right, so we're going to square this thing first. And I'm going to go over here and I'm going to square my t minus 2 times t minus 2. That just means there's two of them. And hopefully you're thinking, oh yeah, I remember how to do this. Here's my box method. So I've got t minus 2, t minus 2. I get t squared minus 2t minus 2t. Okay, so when I start to rewrite this, I get negative 16 times t squared minus 4t plus 4, and then plus 144. I'm going to keep rewriting this. I'm going to go right down here. Negative 16t squared plus 64t minus 64 plus 144. And then I'm just about finished here. So I've got negative 16t squared plus 64t 80. Great. So you've just rewritten it in standard form. So we're good there. Now we want to look and see if we can ask some questions here. Like, which of these points represents the maximum height of the rocket? Well, hopefully you're looking and you're saying, all right, here's my rocket. It goes up in the air and then it comes back down and it splashes into the lake. Okay. So the maximum height of the rocket is at point D. Well, you could probably figure out what this is. If you go back to that original equation, I want to know how this graph gets shifted. Well, we've been working on function shifts all along. So as a quick note, I'm going to put this in here. We've been working on this stuff. Y equals a times x minus h squared. Right? So that tells me that I should be able to look at this equation, and it tells me that it gets shifted to the right spaces, and it gets shifted up 144. Right, so that means that this point right here, this point D, has been shifted 2 to the right and up 144. Right, and that point right there, that's our vertex of this parabola. And it tells us that at 2 seconds, all right, because our height is in seconds, we didn't write that, and our height is in, At 2 seconds, the rocket has a height of 144 feet. Okay. Right, so that's just using the shift that you know. Now, if you look at this question, there are lots of other parts to it. Which of these points represent where the rocket was launched at? Well, you can see it right here. This is where my rocket starts, at A. And what point is that? Well, that's your y-intercept. Every time at your y-intercept, that is always when x equals 0, always. Now, we want to be able to find this point. And we're going to find it in two different ways, just so that you get the practice for both ways. The first way that I'm going to find it is I'm going to go back to this equation here. Okay. So when x equals 0, I'm trying to figure out the height. So I'm basically saying, what's h of 0? Well, it's negative 16 times 0 minus 2 squared plus 144. Or negative 16 times negative 2 squared plus 144. Or negative 16 times 4 plus 144. Or negative 64 plus 144, which is 80. Okay. So that means that at 0 seconds, the rocket had a height of 80 feet. That's its height. So that means that this rocket was not launched from the ground. It maybe was launched from a hill or from a platform, but it was launched from 80 feet off the ground. Now, you guys just find this other, when you had this in standard form, that equation right there, look at how easy that is to find out what happens when x is 0. So if you had h of 0, I would plug it in. I'd get negative 16 times 0 squared plus 64 times 0 plus 80. Oh my goodness, that's so much easier. Okay, so standard form is really easy when you're trying to find this y-intercept. Okay. Now, we have a couple of other questions here, and it just kind of depends on what you notice, what you remember, what you're thinking. So let's take a look, right? So we're on C right now. Which of these points represents where the rocket landed? Well, hopefully you're looking at F. Okay, that's my x-intercept, and it's when y equals 0. All right, so you might remember how to do these ones, or you might not, or you might have to think about it a little bit more. The nice part is that you guys have lots of practice. You can always go into Desmos and type in either one of these equations and find your x-intercept. So what happens when y equals 0? Follow your line, find your x-intercept. Right, when y is 0, find your x-intercept. So follow the parabola until you get to the x-axis. Okay. Well, there are some other ways to solve it. So I'm not sure what you guys have for thoughts on this or what you're thinking, but basically, if you're trying to figure out what happens when y is 0, I'm going to go back to this regular equation here and see what happens. 0 equals negative 16 t minus 2 squared plus 144. All right, well, you could actually make some guesses, right? You could put a 2 in there and see what happens. We already know at 2 seconds it's 144 feet. You could put a 3 seconds in there, put a 3 for t and see what happens. Put a 4, put a 5, put a 6 and solve. Maybe you have some different ideas because we could go to Desmos and figure that out. So one other idea would be to try and solve for t. Right? If you want to try and get that t by itself, we could subtract 144 from both sides. We could also divide this by negative 16. And you'd get t minus 2 squared equals 9. So maybe you're here and you're not really sure what to do, but you know that this has to be 9. Well, you could take the square root of both sides and keep solving. Or you could maybe look at that and say, I know that it has to be something squared equals 9. I know what's inside here has to end up being a 3, or I end up with t equals 5. All right, so some of the other ways that you could do is you could take the square root of both sides. You'd get plus or minus 9 equals t minus 2. I'm sorry, not 9. Excuse me, because I'm taking the square root of 9. Let's try that again. Add 2. I get 2 plus or minus 3 equals t. Wait a second, I get two answers. I get t equals 5, but I also get t equals negative 1. Well, why is that? Why would I get two x-intercepts here? Oh, okay, wait, let me look at my graph again, all right? Oh, if I continued this line, this would come down. I would get another y-intercept. But it just doesn't make sense in this problem because it doesn't make sense to have a negative time. So I'm only going to have 1. I'm going to have t equals 5. And I went into Desmos here, so I'll just show you really quickly what it looks like. But you guys can always use Desmos as well. All right, here's my graph for Desmos. I'm going to zoom in. And if I go down here, I should be able to click on it, and I find that my x-intercept is at 5. Okay. The last part that's here is what do these points B, C, and E represent? And basically all that they're saying is along this route, your rocket could be certain heights. So at a certain amount of time, at 1 second, at 2 seconds, at 3 seconds, it could be at a certain height. So if you notice though, there is something I'd like you to note. Notice B and E. Okay, B and E are at the same height. Okay, so B and E are at the same height. It just means that your rocket's going up and coming back down. So the time is different, but the height is the same for those. Okay, so those are the ones that I wanted to try. What I would like you guys to do is I would like you to try go into your Google Classroom and in your notebook, answer the other two questions that are here, question 2 and question 3, and try them. Try and rewrite it, find the y-intercept, answer the questions of how it shifts, answer both questions, question 2 and question 3. And then when you're finished, make sure you take a picture and you submit it under this assignment. I will post the answers so that you can check them as to make sure that you guys are on the right track and that you understand how to rewrite them, how to find the y-intercept, and all the other different pieces. And don't forget that I am around. If you have questions on anything, Delta Math, you're not sure, please make sure to come into office hours and ask me. I would love to talk to you guys. Okay, thanks.